All right, guys. Okay, let's start this. Excited to be here again. Percona Live online. Um, okay, so let's begin this. Welcome to the monitoring hundreds of RDS PostgreSQL instance with PMM. The Rappi case. Uh, let's start with presentations. I'm Daniel Guzman. I see some familiar names on the attendees. Thanks, guys. With me is Rodrigo Cadaval. There are our emails. You can find us there. So let's make a proper presentation. So right now, I'm the head of data. I live in Cali, Colombia. I was once a Perconian. I was in Percona for almost 8 years. Left in 2020. I love MySQL. I think it's almost perfect. But now I'm in a relationship with Postgres, and it's complicated. There are some things that I really like. There are some things that I don't understand why things are like that in Postgres, but it's a fun ride. So, Rodrigo.
Yeah, well, my name is Rodrigo. I'm the Rappi production DBaaS lead. I live in Buenos Aires, Argentina. I work with Postgres about like 7 years from now, up to now. I love scripting, database operations, everything that's related to automation. And I'm the opposite of Daniel in a way of I love Postgres and I don't have that that appreciation to MySQL.
Okay, so you guys might wonder why we are like driving scooters and stuff like that. So that's because the company that we're working. So to know a little bit more about Rappi, Rodrigo will present the company, and then we will
Yeah,
go
okay.
to business.
Yeah, let's start with what's Rappi. Rappi is the first Colombian unicorn. Unicorn is the title that is given to companies that reach the value of $1 billion. It's founded in 2015 and massively reached the Latin American market after being boosted by Y Combinator. Rappi is mainly a fast delivery company focused on joining customers with infinite type of stores. We are talking about not only restaurants, supermarkets, or drugstores. Let's say, do you want an airplane ticket? Rappi can give you that. A hotel room, that too. Do you want to send money to or send an item to a friend? That's also possible. Do you want to get money from the ATM machine? Rappi can do that for you. So as you can see, there are a lot of verticals involved in this equation. So and they differ between countries in Latin America. And that means that there is a lot of data involved, and it's stored in a huge variety of engines. There are hundreds of Postgres RDS, the mainly thing of this presentation, but also there are a lot of DocumentDBs, Redis, and also MySQL, Dynamo, Mongo replica sets, Elasticsearch, Neptune, and on and on. And well, now Daniel is going to talk about the way that we manage to monitor all these kind of engines, but mainly Postgres with PMM.
Okay, thanks, Rodri. So yeah, what Rodri mentions is that uh, Rappi started as a company focused on one particular business, but it's not been growing very fast, and that quick growth come with challenge in several aspects, but especially on infrastructure. So what we used to have was enough, but now it's no longer that reality, um, especially because more operations on several places. Most of them is Spanish-speaking countries, but we also have Brazil. That's also a challenge in terms of how data is structured, how data is stored, how data is queried. So let's solve business. Why PMM, right? That's why we're here. So when I first joined the company, there was already monitoring and visibility tools. One of them is in the background of the presentation. This, if you guys don't know this, this is Signal FX, a tool from Splunk. And there's nothing wrong with that. Uh, so why add another tool to the equation? Well, because this is very DevOps focused, right? Very sysadmin focused. This is uh, more focused on the health of the server overall, more on the metrics of the machine and probably the OS, CPU, memory, connections, stuff like that. But it lacks of database visibility. And having database visibility, it's something that it's cool, right? But it's not only cool, but also kind of necessary. Um, what do I mean with database visibility? Like what's wrong with CPU or memory or disk queue or whatever? There's nothing wrong, but it's hard to know what is the context, right? It's hard to know uh, where is that CPU usage coming, right? It's hard to know how it's affecting the rest of the database. Databases are very complicated beasts, and it's the like ultimate definition of shared resource usage, right? So it's everything competing for the same resources to access data, to access fast, to retrieve data and return data fast and at the same time, right? So databases deal with this concurrency with different uh, set of tricks like mutex, chart structures, or whatever. But at the end, everything is the same resource, the same CPU cores, the same memory, the same disk, the same network, usually, right? There's sharding or stuff like that, but usually it's like that. So, okay, cool. We have um, alerts on monitoring CPU, right? Okay, of course. We had a problem. It Where is the problem coming from? It's from that query that it's taking 10 seconds, or it's because there's a vacuum process that kick off at the runtime, or what is it, right? So uh, database visibility, it's what's going on inside, right? Like when you connect to the client and start to see registered activity or process lists in MySQL, right? Uh, that give us an advantage in terms of knowing what's the context, where we need to focus our efforts. That's why we decide to go with a monitoring system. Um, I'm a former Perconian, so I was very tended to PMM, but we did saw other options. Truth is that we used to have, we still have DPM, the former Vivid Cortex. um, which is a great tool, but it wasn't enough. It's very focused on queries. It does it pretty good, but it wasn't enough. It's a SaaS. It's hard to customize. It comes with a cost, monetary cost. So that's why we decide, okay, let's go with PMM. Fantastic. So what was the goal um, of using PMM? Like how we as Rappi are going to measure success of using this tool? Well, first of all, the goal was to monitor all DB databases. We have all app databases. We have data warehouse. That's another story. We have to let's focus first on LTP databases. As Rodrigo mentioned, the majority of the databases are Postgres. Then we have a huge amount of DocumentDBs. For the ones who don't know what DocumentDB is, it's not a replacement, but it's based on MongoDB, and it's AWS proprietary technology. It's the Amazon version of Mongo. It's not 100% compatible, but it does the work. It's kind of self-managed because it's part of Amazon. So we have a lot of those. We also have some MySQLs in all kind of flavors. We have Community, we have Aurora MySQL, we have MariaDB, a couple of MariaDBs, and also a bunch of MongoDB replica sets, proper MongoDB running on EC2 instance, running Percona server of MongoDB, still on 3.6, looking forward to go to 4. But right now, that's what we have. Okay, so it's very heterogeneous, and mostly it's Postgres. So let's focus on Postgres, and we'll see if we can use that tool for something else. That will be a plus, but it's not like the main goal. There was one detail. We are an RDS shop, right? So we have hundreds of database instances, all of them RDS. Postgres RDS, not even Aurora Postgres RDS, 100% Postgres RDS. Okay, what does PMM offer for this kind of situation? So when we were doing the capacity planning and thinking, okay, how we're going to deploy this, how much resource we have to dedicate, not only computing resources, but also like people or hours of maintenance or whatever. The Not the first thing, but the thing that was worried the most for us was that since it's RDS, the PMM client will run in the same server as the PMM server container or VM or whatever. It's gonna run, right? So you need to think that you need to dedicate resources not only for the PMM server, which is not that kind of resource intensive, but also for the exporters, right? Why? Because RDS, it's a box. You don't have access to the EC2 instance where the database is running. You just create an instance. What Amazon gives you is an endpoint, the credentials that you have, and that's pretty much it. So that's the reason why PMM client needs to run in the same server. And what's PMM client? Well, in Postgres case, is the Postgres exporter and the Quan for the query analysis. And if we're going to add MySQL, it's the same. MySQL exporter, Quan exporter for MySQL or Aurora, plus MySQL comes with the RDS exporter, which collects the CloudWatch matrix, or if you have case monitoring, that's additional thing that we'll collect and we'll send to the PMM server. So there's a lot of processes running. It's not and it's a process of itself. It's not that one main process is spawning new process or creating threads from the same process. No, it's a process by itself, all of them. We're talking about 500 instance, give it or take, um, just of Postgres, right? So that's a lot of things, couple of exporters per instance. We wanted to leave the default 30 days of data retention. So that's another thing. How much disk space it's enough, right? Um, we didn't knew at the beginning. So when we start and we deploy and start to collect data, we were kind of looking the behavior on a daily basis, then a weekly, and pretty much 500 gigs of database seems to work for us, especially now that um, PMM moved out from Prometheus and now it's on vertical Victoria metrics. Sorry, uh, disk space it's less of a concern now. What we did saw was that when by using Victoria metrics, the CPU usage increased. We think that it's because something else, but we're getting to that. So, what was the final server? Right now, we are monitoring the 500 instance on an C512X large instance, EC2 instance, on a dedicated tenant running Ubuntu 2004, the LTS, the long term. PMM is deployed as a Docker container. Why not as the so PMM? There are options to deploy. One option that it's available when you're using Amazon is that PMM is available from the marketplace. Why we didn't use that? Pretty much because we have the in-house knowledge on managing this as a Docker container, right? So it's less hassle in terms of the relationship with Amazon, or we can. And personally, I feel more comfortable running PMM as a Docker container because that's the way I always have used PMM. I'm using PMM since version 1.0. I don't know, very early. Right now we're using latest, which I think is 216 or 217. I don't remember well, but it's there. This server is enough. We started with I think it was an 8x large. We have to scale it up, but not immediately. Like 2 months later, I was never sure why, but we have to scale it just once, and it's running in 12x since there, and it's working fine. We have no problems. Okay, so we have the server, fantastic. Now let's talk operation. How to add hundreds of RDS instances to PMM. Okay, so let's remember, we don't have the option to use PMM client. We cannot go and install the Percona repo, install the PMM client package, configure and add Postgres or add MySQL. That's not an option, right? What does PMM offers? There's a graphical interface to add instance. There are several options. When we start, the only option for external Postgres, for Postgres instance on RDS, was to add a remote Postgres for the SQL instance. Can you imagine doing that for 500 instance, one by one, looking for what's the endpoint, What's the name? Let's put the power, the label. That was not an option. So how do we solve that? By using the API. Um, I'm not sure how much it's a known issue that the API is available through the Swagger interface on PMM on your local in any PMM deployment. You can just go your IP, or if you have a CNA or whatever, DNS or whatever, use there and slash Swagger, and then you have access to the PMM API. This is not actually what we're using, right? Because it's also a graphical interface, so it's it's not good. But this is very helpful to know what's the data payload, what are the variables that every method of the API is expecting, what will return. It's good for testing, but it's not a production ready solution. So how do we? What was the solution for us? We wrote a nice Python script for it. So that's just an extract of the script, and it's pretty much a script that use the AWS API to get the DB instance. Some of the properties of the instance that we need, of course, the endpoint, DB instance name, what else? Some custom tags that we use internally. I like to store the instance type. Well, that's also, I think it's an option. Instance type, availability zone. I added some tags like what type of EBS this is using, if it's using general purpose or IO1 or whatever, if there's multi availability zone enabled or not. You can add whatever you want on tags, but it's pretty much enough if you add instance name, the endpoint, user and password, port, and that's pretty much it. So this is just a script that goes query the API, the Amazon API. It gets the result for all the RDS for Postgres. It's also work for MySQL. You just need to change the storage filter. But that's another API method. So you have to be aware of that. You have to look what API method you want. But bottom less, the whole process of adding the 500 instance it takes probably 1 minute, probably less. It's pretty much tied to the response from the API, Amazon API. That's it. Boom, magic, fantastic, it works. We're still using this, and from time to time, we don't have a dynamic inventory. We do have that for Ansible or DynamoDB, but we don't use it. What we're doing is we delete all the nodes with the agents and the services and run this again. So that's how we have pretty good image of what instance we have. If there are new instance, it will be added. If there's an instance that we're no longer using, it will be removed. And that doesn't delete the data, right? You can delete the node and the agents and the server, but the data will remain. Data only will be deleted by the retention policy. So there's no issue with that. Okay, so after we have the instance, cool, great. We have metrics, fantastic. But there was a lot of them. And I don't know if some of you guys that are watching this have deal with a PMM deployment with several nodes. the default home dashboard, the home dashboard by default on PMM, it's gonna kill you. It's gonna kill your uh, Google Chrome or whatever you use to navigate, because it will have a row per instance with some metrics that I don't remember anymore, because I removed that. I changed the default home dashboard. I changed it for something else. What is that something else? A custom dashboard that we did. With what? With key info. Why? PMM comes with dashboards. Uh, for every technology that it monitors, MySQL, Postgres, and Mongo, it has an overview dashboard and a summary dashboard. But for the amount of instance and the data that we want to do, it wasn't a good fit. It has a lot of info that I personally I don't need. It's noise for me. I just want to focus on very key stuff. So that's why we built a custom dashboard, and we added something that is called Z-score. Z-score, it's just a fancy name for an equation that told you how many standard deviations you're away from the mean of a signal, a metric, right? We're using that for connections right now on different tools, monitoring tools. We use the same something similar, something for anomaly detection for CPU, but for PMM it's just for connections. So that's the Z score. It's an equation, right? So Prometheus or Victoria metrics, you can do equations, right? You can put like the rate of this divided by whatever, and it works, right? So that's what we did at the beginning. What was the problem? Our dashboard died, but this time was not because the amount of widgets from the dashboard, like or graphs or information, whatever, but it was because the all the calculation was, and it's still is very expensive, right? Because it's a lot of data from a lot of nodes that needs to be calculated very frequently. So that was a problem. Okay, we have metrics, but it's kind of useless. Not useless because we can go to the summary. The summary dashboard was already useful, but for the overview, we're still blind. So how do we fix that? Is there a way to pre-calculate this stuff? And yes. How? By using rules. So Prometheus, like the vanilla Prometheus, how is it called, project from the Cloud Linux Foundation or whatever, comes with rules for Alert Manager. We're not using Alert Manager. We're using something else for that. But it has these rules for metrics. How does it work? It just pre-calculates this, execute the query, the equation, and then you can access the result of that by using the name that you put on the record. For example, the first one, instead of you using like pgstat activity count, which is a metric that it's directly from the Postgres exporter, I can use your service name, pgstat activity count, average, and that will be this expression already pre-calculated, right? So instead of doing the math operation every time I refresh the dashboard, it's just pre-calculated, and it will be available faster it won't kill your dashboard, and it will help also the server because it will spread this through time, right? And it will help anxious people like me. So this is this is a very cool trick. If you can see, there's the C score. The C score calculation is somewhere there. I don't see it, but total sum. Well, it's in there. Here it is. C score, and C score it's already using the pre-compute of other query operations, right? Like this one, start activity count average 10 seconds. That's another thing that we're doing here also. So it's gonna help you a lot to have faster graphics. So we also made some customization, the summary dashboards. Um, we added some of the tags that I would like to add, like the multi-AZ, the storage type, some things internal from the business. We enabled gzip on the Grafana configuration, which is disabled by default because Grafana says something related to um, consistency that is not going to work everywhere. So please enable. It will save you uh, probably 3 to 10 seconds of load, the whole dashboard, not the refresh one. But the first time, it will be way faster. We try to avoid legends also. That I don't know why. That zooms time of the render of the graph. Okay, what was next? Collector. So we became very happy with PMM, and we also became very ambitious on the info that we wanted to store and graph. But so the first source that we wanted to use was the exporter itself. But PMM was first a MySQL tool, then a Postgres. So MySQL exporter is very, very complete. Postgres is not there yet. It will be there soon, I guess. I hope. But there are missing key things missing, right? Like more detailed vacuum info, info about wall operations and replica. It's very basic. So luckily, PMM has a way to. I mean, we can just modify the exporter or some things and recompile it. It's a Golang code, but I didn't want to risk that, so we just go with options that PMM has. We use both custom queries and text file collector. Custom queries, it's pretty much using a query in a YAML file that you can put inside your Docker PMM server container. And you just tell PMM what it's a label, what it's a cow, what it's a counter, whatever, some description, some name, and that's it. You can say, there are 3 directories for custom queries. Well, before that, there's a MySQL directory and a Postgres directory for custom queries. And some of them, you have high frequency, medium, and low. This vacuum query is kind of expensive, so it's in the low frequency. You just put in there, it's a YAML file with some format that it's in the documentation, and that's it. It will start to collect it. No, that's it. No, every time we have to restart the container. I don't know why. It should be like plug and play, but it's not. But it works. So we have that where we made some new dashboards for vacuum. Um, we 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 have info on vacuum that it's additional, not only from the exporter. So the same thing was for another thing that we want to have graphs, which was the table size. But for that, we wrote a Python script that just calculates, go instant by instant, that database by database on the instance, and get us table size, full table size, the index size, uh, index plus data size, whatever, and then it wrote it to a plain text file with the properly format. Also on the documentation, if you can see if you want to see the details, one line per metric, and then we just move that file when it's full to another location inside the PMM server container. PMM will just add that data to Prometheus, or now Victoria metrics, and that's it. You have more metrics available, and you can graph that. You can put alerts, whatever. But the option it's there. Bear in mind that with high amount of nodes, all this stuff takes time. To give you an idea, the script that calculates the table sizes, it takes 2.5 hours to finish every time. So we just run it once per day. Things that happen when you have big infrastructure. So one of the topics that we wanted to talk about was some hacking that we had to do, and this was gonna be the slide for hacking. And let me tell you what was the big hacking that we did. It was the CloudWatch metrics when you're using Postgres. So I mentioned earlier that when you have MySQL RDS or RDS, there's an option to add Aurora or MySQL RDS, right? And it will add everything, the MySQL exporter, the Quant exporter, and the RDS exporter. That was not the same for Postgres, right? So if for us to have CloudWatch metrics on PMM, we were doing some weird stuff. So pretty much was this. I was adding Postgres with the API on the Python script. Then I forced to add the RDS exporter that will create the agent, and that will create a configuration file. And that configuration file will use the endpoint, the DB instance name for endpoint instead of the actual endpoint. So once I forced to do that, I wrote a very horrible bash script to replace the DB instance name for the endpoint, and force the agents to be to reload the configuration file by doing a kill, force to restart and read the new one, and have to wait a couple of minutes, and then CloudWatch metrics appear. But now you don't have to do that. And this is a big shout out to the power of the open source and the power of community and how things works and really works. I did not only did the hacking, but I also reported the bug. I reported several bugs. One for Quant issues with not with ClickHouse, but with the agent. One with Rodrigo.
Yeah, one with the table statistics that were not the.
Yeah, so um, in a matter of months, this bug that I reported was fixed, and I don't know if we're gonna use my solution. I just put in there, but now it's working. So now PMM works for both Postgres and MySQL RDS in the same way. You can add them uh, using the AWS key as secret, and it will add the properly exporter, the Postgres or the MySQL one, plus the RDS. So that's it. No more hacking. Now I'm using the regular path. So kudos for that to PMM, to the whole Percona team. There are other bugs fixer in progress. One is for usage of the ARN format of of how Amazon stores the whole information of an instance. But let me explain very well. We have instances in different regions, whereas is different accounts. So that let us have duplicate names, right? We can call one RDS database one, and we can call another RDS in another account database one, and we will not have no problem because there are different isolated instance on different spaces. So when we wrote the Python script to add it, at first I didn't notice that, but the ones that had duplicate names, it was adding just one, right? So when I figured that was the problem, what I did was like, okay, I'm going to add the name, like the one that PMM uses as a unique identifier, as the name, right? And that includes the account, the region, and the account region, and the name, and the DB name. I would say, okay, cool, let's use the ARN. ARN has a colon, and it's not working. If you add that colon, it will break PMM because something with the variables and something internal, if one wasn't work, whatever. So I just have to do some concat of that info, but using hyphens, and then it's working. That I know that's that reported. They're working on it. There was another bug that it's already fixed, and it was with Quan. So Postgres, when you connect, you have to give the database to connect, right? It's not like MySQL that it just connect to nothing and then you use tests or use whatever database. In Postgres, you have to provide that. If you don't provide that, it will use, in Quan, it was trying to connect to a database with the same name as the user that you're connecting. And if that database doesn't exist, there were some features that wasn't working, like getting the table structure index or examples or whatever. That was fixed also. Rappi reported that, Percona fixed it. But now when you have several databases inside the same instance, it will create a lot of connections, right? Once per, especially when you're using custom queries, it will add CPU for that. So that's a challenge also. Like if you have several databases in the same instance, be careful with that. And there are some other bugs that are still on it. But like I mentioned earlier, after Postgres, the next technology that we in Rappi use mostly it's DocumentDB. And since it's based on Mongo, I'll say, okay, cool, I can use PMM for this. Wrong. The MongoDB exporter doesn't work for DocumentDB because it connects whatever handshake connection established, but then the first operation is to get some stats from the database, the instance, and the format that document provide, the JSON or the dictionary or whatever it's called, returns, it has a different syntax from the one from Mongo, so it doesn't work. I just create that as a feature request. It's in there. If you have the same problem, go both. But it's not working. However, we do have the MongoDB replicas monitoring with PMM. That does work perfectly, especially because it's MongoDB by Percona server for MongoDB, so it should work. So that's pretty much it from our journey. We have some time. I don't know if you have some question. I don't know if Rudy wants to add something.
No, just to say that recently, right, that issue is going to be fixed estimated in 3 weeks, the one related to DocumentDB. So that's a good thing to know.
For guys that don't know Roma, he's the responsible for all this for PMM. So whatever he says, I will believe him. Okay, so fix it to 3 weeks for 218. Fix it. Which one is fixed 2 days ago? Okay, no. That's for bug. So Roma, can you commit with a time frame for DocumentDB? That will be great. Okay. We do, of course, we also have MySQL monitoring with PMM. That's kind for granted. But like I say, PMM was primarily made for MySQL. So our journey, the interesting journey was with Postgres. I also want to mention that by having PMM now working, especially Quan working properly with Postgres, we're now able to not use any more DPM with Cortex, right? So that's a win in terms of less things to worry about, and in terms of course, monetary cost. So that's another good thing about the whole open source community. There are some things with Victoria metrics on that sometimes it hits like a CPU. I haven't been able to repeat that, so there's no bug report yet, but probably soon. Okay, so is there any other questions? Yeah, I'm seeing that our script, we cannot share it, but we can say that regular Python 3, of course, 3.8, using Boto, the AWS library to use the API for AWS. And that's it. It's just knowing which API methods to use. But that's it. Okay, so yeah, for Quan, we're using pgstat statements instead of pgstat monitor, because pgstat monitor, it's an extension that you have to install. And since we're on RDS, we are limited for what RDS offers for extensions. RDS offers extensions uh, like PG Audit, um, Postgres, yeah.
Yeah,
Uh,
there are a lot.
so that's why we will pretty much like to use PDSL monitor, but we cannot do that right now until we move out of RDS, which is one of it's in our plans for I don't know the year 3000. It's in the plans. Yeah, PDSL assignment it's an extension, but it's powered by RDS, so you just can install it and that's it. Yeah, I will have to have. I'm reading the chat. So, if if you guys from Percona can make Amazon to Apple Star Monitor one of the available extensions, it will be amazing. Pretty good. Um, and also, friendly request for give much more love on like by default from PMM. There's nothing related to HA or replication on Postgres. If you go and install MySQL, you have dashboard for, of course, the replica lag, whatever. Um, PMM also even have dashboard for HA proxy or proxy SQL, but for Postgres is not quite complete there. I'm not talking about like PG bouncer or what. I'm talking about like replication slot statistics, wall statistics with the dashboard by default. That will be amazing. Um, what else? But vacuum activity. Um, well, those three will be will be great. So PMM, the proxy SQL exporter collects, I think it's only two or three statistics from wall, but there's no dashboard using that. Like for a graph, and you let, let me tell you this: when you install PMM, you have an example a file for custom queries, an example YAML file with a query commented. That query is the example query is to get the replica lag, but it's commented, right? So there are some things um, that that are collected but not visualized. Um, so, but they're missing things. The slot operation that will be a huge win. I don't know what else, but I think I already said everything. So thank you very much.